Welcome back to AP Pre-Calculus. Today's lesson 1.12 is transformations of functions. Okay, a lot of this lesson should be familiar to most of you guys, especially if you had me last year. We did the 1, 2, 3, 4 a lot. If you remember, the first thing I always like to talk about is a vertical translation, and that would be if we had a plus sign or a minus sign outside of parentheses, that would shift our graph up and down. If we had a plus or minus sign inside parentheses, we had a horizontal translation, and to figure out what it was, we would set that equal to 0, right? And so it basically did the opposite of what it looked like. Like if it was a positive 3, we'd say it shift left 3 because it would negative, it goes to the left, okay? And then if we had a number out in front of the parentheses, that was our dilation, and that would our you could say stretch or compress, right? And if it was negative, it would reflect over the x-axis. Here's the new one, because last year we didn't have any numbers in front of the x inside the parentheses. And if you remember over here, inside the parentheses is horizontal. So it's the same idea if there's I'll call it a coefficient in front of the x. It is a dilation. But just like over here where we would basically change the sign, we did I don't like to say the opposite, but basically we did the opposite of what we saw. So if we saw a plus, we'd say we go negative, so left. Well, over here, we're going to do the opposite. So if it looks like it's multiplying by 2, we're going to say that it has a horizontal dilation of 1/2 divided by 2. If this was x over 7, like divided by 7, we'd say it has a horizontal dilation of 7. We would do the opposite of what we saw. And if it was a negative, we would flip over the y-axis. Over here, we flipped over the x. Here, we'd flip over the y. Okay, so we're going to do this, and we did this last year in Algebra 2, but here in AP Pre-Calculus, we have to make things look a little bit better, so we're going to maybe not use the same words that we used last year. And basically, I'm just going to go from left to right, and I'm going to start with this 2 right here. It is a 2 on the outside of parentheses, so that means it is a vertical dilation, and then we could say of 2, right? So last year, all we did was say, oh, it stretched or it compressed, all right? But this year, we're going to call it a vertical dilation, and then we're going to name of whatever it is. So the next thing I get to is inside the parentheses, and last year, we would say it moved right 3, and that is great. Yes, it definitely moves right 3, but on the AP exam, it's not going to say in the multiple choice section, it's not going to say moves right 3. It's going to call it a horizontal translation of positive 3, okay? So with that information, we should be able to answer this last part, this +1 on the outside. We would call that a vertical translation of positive 1. Okay. All right, let's try again. Moving from left to right, we have a vertical dilation of 4, and it reflects over the x-axis. So that takes care of the -4. And then I move inside to the 2, and it's a coefficient, it's a multiplication. So we also have a horizontal dilation of not 2. Remember, it's kind of the opposite of that. So in this case, of 1/2. Okay? All right, so here in example 3, they want us to take this graph and they want us to draw it again, but following what they've told us to do. So we have this function g of x that takes the f of x function that's in the graph, and it's going to do x plus 3 in the parentheses. So that's going to tell me to shift it 3 to the left, and the -4 on the outside means to shift 4 down, right? We're going to do it a little bit different, though. We're going to take the ordered pairs, and we're going to move the ordered pairs. We really wouldn't have to do it on this one, but I'm trying to get you ready for some tougher questions here in a minute. So what am I doing is my ordered pairs are x comma y, right? So when I do the x of the f function, I'm going to have to subtract 3 because I'm moving 3 to the left. And when I take my y of the f function, I'm going to subtract 4, right? And remember, this is my f function up here at the top, the graph. So what is this first point right here? That is negative 3 comma 4, right? What about this next one? 0 comma 1. We'll do this one, the next one, 3 comma 1, and then 5 comma 1. I'm going to take all of those and I'm going to shift them, right? So I'm going to subtract 3 from all the x values. That's going to give me negative 6. It's going to give me negative 3. It's going to give me 0. And it's going to give me 2. And then I'm going to subtract 4 from all of the y values. That's going to give me 0, negative 3, negative 3, and negative 3. All right? So let's plot those. Use a different color here. Let's blue. So negative 6, 0, boom. Negative 3 right there. 0, negative 3 right there. And 2, negative 3 right there. And this is probably going to be my zoop. And then I can just connect these. And notice, all I did was shift down 4 and left 3, right? Now, could we have done that without doing the points? Yes, but on the ones coming up, it's kind of important that we do the points, okay? All right, we have this weird looking function here with a hole in it. So they call that the h function, right? And so what we want to do is we want to make a new k function that takes the h function and multiplies the x's by 2, adds 1, makes it... So there's a lot going on here. So let's talk about each one of these things. What does a negative in front do? Well, that's going to reflect us over the x-axis. So it's going to invert this thing, right? What does the 2 inside do? Well, that means it's a horizontal dilation by 1/2, which means horizontally, this is going to be half as big. So it's going to be a lot shorter left to right. And then this +1 on the outside shifts everything up 1. So what does that look like to my h values? So my x of h gets cut in half because everything that's done to the x value is inside the parentheses. My y of h is being made negative and it's adding 1, okay? So these are the transformations that I want to make to these points again, all right? What points do we want to use? Let's just go left to right, okay? So my very first point is negative 4 comma negative 3, right? So if I did my transformations to that, cut x in half, so I'm at negative 2, make the y negative and add 1, it's 2, negative 2 comma 4, so right up there, right? And then go to my next point. I'm going to do the v up there at the top. That is negative 2 comma 1, right? So let's cut it in half. Negative 1, make the y negative, add 1. So I'm at negative 1, 0. So there's my first part right there. All right, the next v is, what is that? 0 comma negative 2. I'll cut it in half. The x is still 0. Make it negative, positive 2, add 1 is 3. So back up here. Make that, all right. So I don't have any more v's, so let's jump to the whole, all right? What is the whole? The whole is 4 comma 2. So if my whole is at 4 comma 2 on h, where is it on k? Well, let's cut our x in half. That's a 2. Make the y negative. Negative 2 plus 1 is negative 1. So 2, negative 1 is where the whole is going to be. So I can come down here. And our last point is, what is that? 6 comma 4, right? Let's cut the x in half. That's a 3. Make it negative. Negative 4 plus 1 is negative 3. So 3, negative 3 is right about there. Makes a nice little line there. Probably should move our dot that we have there. What is that? What is that dot at? Let's go over here. That is 4 comma negative 1, right? Cut your x in half. That's 2. Make it the y negative. Positive 1 plus 1 is 2. So 2 comma 2. We have to put our dot right there. Okay? And there it is. Notice that the total width of that is about 1/2 of what the original one was. And that's what we were expecting. So here's the graph, but we're not going to regraph this one. So let's go ahead and look at our new function. We have g of x equals 2 times the function of x plus 3 minus 4. So again, we have a lot of things going on. All right, so here we go. We got our x of f. What's going on inside the parentheses? Well, it's a plus 3, so it means we're shifting to the left. And what's happening to the y value? Well, it's being doubled. All right, the y of f is being doubled, and then it's being subtracted by 4. All right, so to do our domain and range, we don't really have to re-graph this and look at the graph. We can just look at our endpoints for the domain. You see, we have endpoints of negative 3 to 5. We're just going to use the x values, right? So I'm going to take my negative 3 and subtract 3. That's going to give me negative 6. And then I'm going to take the 5 and subtract 3. And that's going to give me 2, right? So that's my domain. And for the range, we're going to do the same thing, but we're going to do the y. So my range, I'm going to look at 1. I'm going to double it. 2 times 1 is 2. Minus 4 is negative 2. Double the 3, that's 6. Minus 4 is 2. So there we go. All right, here on this question, they give us a table of values. I think these are a lot of fun. Like if I said, hey, what are you going to get out if I put in a 6? You would go to the input, the x values, you find 6, and you would just say 7. Well, this for the p of x function. We're talking about an h function, and what is it telling us that we're doing? We're doing all of this stuff right here to the function. But down here, it's saying, hey, let's put a negative 1 in for x. So now all we're doing is substituting. We're going to take the x out, we're going to put negative 1 in, and we're going to figure out what we're doing here, right? So if I come over here and I put a negative 1 right there, I'm going to get 2 times negative 1, which gives us negative 2. So I want to do p of negative 2. So I'm going to come up here to the p function, right? I'm going to put in a negative 2, and I'm going to get out a 1. All right? So now all of this became a 1. So now I'm going to do 3 times 1, 3, minus 1 is 2. Okay? Let's try b. I'm going to put 2 in for x. Well, 2 times 2 is 4. So I want to do p of 4. So I'm going to come up here. Well, where is my input? 4. There it is. My output was 3. So this p of 2x becomes 3. I'm going to do 3 times 3, 9, minus 1 is 8. Last one. I'll take the 0, put it right there. 2 times 0 is 0. I'm going to come up here, p of 0. There's the 0. I get out a negative 1, so it's 3 times negative 1 minus 1, and I get negative 4. All right, we got a total verbal question here. We don't have any graphs. We don't have any tables. We just got words, all right? The function g is constructed by applying 3 transformations to the graph of the function f in this order. We're going to do a horizontal dilation by 3, a vertical dilation by 4, and a vertical translation by negative 7. All right, so we need to find the values of a, b, and c. So let's see what we should do here. So I'm going to start with g of x equals, I'm going to use f here, right? So I'm going to start with a. So a is a vertical dilation, and it says it has a vertical dilation of 4. So that goes there. I also have a horizontal dilation. Remember, inside the parentheses is kind of opposite of what you think. So if I have a dilation by a factor of 3, that means I must have had a 1/3 in there with the x. And last but not least, the easy one, vertical translation. There's nothing to really do here. You just put minus 7. This is not what they asked for. They want the values of a, b, and c. So I got A equals 4, B equals 1/3, and C equals -7. And we want to make sure that we're doing it this way because on the AP test, they might ask you questions like, what is the sum of A and C? Right? So you'd have to say -3 because you'd add the A and the C together. So they might ask weird questions, but you have to get to this point first. All right, this one is kind of putting the last two of them together. So I'm going to build the function first. So let's go ahead and read this. So the table gives us values of the function h at selected values. Let k equal this. We want to find a, b, and c. So let's write out our k function. All right. So we got k of x equals. What kind of transformations do we have? We have a horizontal dilation by a factor of 1/2. So I know that this has got to be 2x, right? Got a vertical dilation by 3, so there's a 3 out there, and a vertical translation of 1. So I believe that is what our function would look like with our a, b, and c. And then we can just go and do the stuff that we did a couple examples ago, all right? So we want to find -6. So we're going to put -6 right here. So 2 times -6 is -12. So I want to go up and look at my input at -12. I get output at 1. So now it's 3 times 1 plus 1, and it's that easy. All right, so we're given a function p. It's a linear function. It's 3x minus 2. And we want to find the values of a and b for the function r. So the graph of r is the image of the graph after a horizontal translation of 4. Remember, horizontal goes inside parentheses. So we know that it has to be, and since it's a +4, it would be -4 on the inside. So we are looking for r of, oh, that's not an r. R of x is going to be the function p when it's translated. So now I'm just going to take this x minus 4 because that's my new input, and I'm going to go up here, and I'm going to take 3, and instead of x, I'm going to put x minus 4 minus 2. Right? And then I'm just going to clean that up. I'm going to distribute. I'm going to combine like terms. 3x minus 12 minus 2, and I get 3x minus 14. So r of x is equal to 3x minus 14. But that does not answer our question. The question is, find the values of a and b. A equals 3, b equals -14. Again, the reason you want to make sure that you're doing that is because they might ask you on the test, what is the product of a and b? And you'd have to multiply those together. Okay, that's the end of this lesson.